Yeah, hi. Good evening, everyone. So we have this session for week 12. Okay. So as we have already mentioned that week 12 is not in the syllabus for the end-term exam. Okay. So now this is actually removed from the last term from the syllabus, but before that it was the content of the PDSA. So professor have removed it because it is not too much relevant in the terms of DSA. But yeah, some uh, topics are actually interesting. So we today we have this as a text for this discussion for these week 12 contents. Okay. So any query before starting the session? Any doubt? Anyone? And
I do have one question.
yeah, Nuvama.
That is related to the fail function.
Fail function in the week 12. Yeah, you are talking to the
Y-
same week 12 content,
Yes.
correct? Okay, okay.
So sometimes you are given the algorithm,
Hmm.
which is you're just the name of the algorithm is given, and then you are told to do whatever you have to do, which is now out of syllabus.
Mm-hmm.
Sometimes I've also seen questions where there is no mention of any algorithm. It's just a simple code that is given, and then
Okay,
we are told to find the output of the code, which
okay,
technically may not be called Week-12 because there's no mention of any algorithm that you need to remember. It's just a piece of code. You have to parse a string through it and then give the output. And the code happens to be called a fail function. So is this kind of question going to come in the exam? I mean, because it is actually Week-12.
uh so you are referring any question from the past year, that QP?
Yes. So around two QPs ago, two terms ago, there was a question where the code was given, entire code was given. You had to take a string which has
And
input
that
and run
that
it through the code and give the output.
that question was from the week 12 content, the string matching algorithm you are saying?
It was not string matching, it was just a fail function. So it was that you are
Okay,
given
okay,
a
okay.
string
Yeah, that actually that fail function is the part of the KMP algorithm from week
that I
12.
know, but they didn't mention the word KMP or anything anywhere. It was just a simple Python
Okay.
code and string. So can we expect that or
No,
no?
no, not required because that fail
Okay,
function is discussed in the week 12 under the KMP algorithms. So
that
at
I
that
know. Yeah.
time, actually at that time that week that contains was in the syllabus. So we expect that everyone know that what are the purpose of that fail function.
Okay.
Okay, and that code is already given. If anyone have not that watched that lecture or not that code before that, otherwise there's no required to use that code with for that question. Actually, if you know
Mhm.
already what is the purpose of fail function.
Okay. 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 Thank you so
Okay.
much.
Yeah. So any question from week 12 is not supposed to come in the final exam. Okay, this time because this is completely removed from the syllabus. This is just released as an extra content, so you can explore some more
Understood.
things. Okay. Yeah. Okay. Anything else from the other week? Because next week we are planning to conduct one revision session, basically from after week 8. Okay, because before quiz 2 we have already done the revision session. You have already given two exam till week 8. Now the remaining weeks are week 9 and 11. Okay, so we will conduct one revision for to discuss the questions related to that week. Okay, otherwise the you can watch the previous revision session, or maybe we will ask to TA, so maybe that he will revise little bit something or anything if you want.
So can you revise those concepts in the last part of week 11, NP, NP hard, NPC? So I'm not able to solve the question related to this topic in the PYQs.
Okay, so
Uh,
that part will be covered in the revision session. So because of that we are saying week 9 and week 11 we will conduct the revision session only for that. And in the week 11, I am also telling you the what are the important topics only, that linear programming related question, and maximum flow, and this NP theoretical that questions. Okay, so these are the three topics. Generally, we ask the questions from that. And if you see the previous that previous year PYQ, so most of the questions are from only these three topics. Okay, so if you can practice on the PYQ questions, so you will get the similar type of questions in the this exam also. Okay, but we will revise these 2 week again in the next week.
Okay.
Sir, can you do this matrix multiplication in PDSA book? There's this problem example given. So I was trying to do it, but I was not getting one of the values.
Okay, that notes you are asking, that the example is given.
Example in PDSA notes that's given. Book. So there is that matrix C which has been worked out, right? I was trying to work it out.
Okay.
So
And
one
you
of
are
the
not
values
getting.
I was not getting. So I was wondering where I'm going wrong in that.
Okay, let me share my screen and quickly check. Okay. You are referring to week 9.
Matrix multiplication.
So last this example you are saying?
Yes. So that 1080 value, I've got the rest. I've got the diagonal before that.
Okay.
I've got that 264, 1320, and 1140. After that, when I was trying to calculate the 1080, I'm not getting that value.
Okay, this value you are not getting. Okay, one second.
These type of questions are quite lengthy. It takes around 7-8 minutes to solve.
Yeah, so this is actually, you have to use the induction function in the every time, like this induction function. Okay. Yeah, someone is speaking in between. Okay, so basically what we are doing, we are using this inductive function. Okay, so this inductive function, what we are doing, we are passing the k value from I to j. Okay, I2 less than j, 1 less than j. Okay, so for all these value, we will figure out the values, and after that we will select the minimum one. Okay, so we will use this inductive structure in this, and the same inductive structure is used in the that example. So I am just writing this inductive structure and will do. Hello, am I audible?
Yes.
Yes, sir, you're audible. You're audible.
Okay. Okay, so regarding this example, let me take this. Okay, so as you mentioned that you have got the answer for this one. Okay, this
I've
one.
got it up to 264. Yes, that
Yeah,
I've
this
got.
one. Okay,
Yeah.
and for here you stuck. Okay,
Correct.
so first thing we will just use the matrix. So how many matrix we have? M0, M1, M2, M3, M4. So this is the same things: M0, M1, M2, M3, and M4. So this is the things. And okay, so 0 to 4, this is fine, and we have filled this, and we are trying to figure out this one. Okay, so 0, 1, 2, 3, 4. So same indexing we are using the above, and same here. So now for this point, okay, so 0 to 3. So that means we are taking this solution here. So that means this is the I value and this is j value. So that means C, I is 0 and j is 3. So this value we are filling here. Okay, and what we will take, we will select this CIK formula. Okay, so main of, and now we will put all the value which we need actually. So CIK, so a k value we will start from 0, 1, 2. Okay, not we will not include this 3. Okay, so that first, yeah, for this k value we will check the value for k when k equal to 0. So what will be the formula for this? Okay, so this is c, I is remain 0, so this is I and this is j and this is k. So k for 0, so c I k, so that means 0 and k will also be 0. Okay, plus c k plus 1, so c k plus 1 will become 1, and that is j, so j is now 3. This is the another one, and what we are taking, this is the dimension of the matrix we are taking. Okay, so for this dimension we are taking this I, and this dimension is representing for this list. Okay, so this is the nested list we have. So this is 0 matrix, and this is 1 matrix, this is 2, this is 3, this is 4. Okay, and inside this we have the index 0 and 1 for each. So the same dimension we are using here. So now dimension, that means dim, and this is I is 0 and 0. Okay, into k1. Okay, so that dim k equal to now 0 and 0, 0 and 1, sorry, 1. Okay, and now last is j and 1, so that multiply dim, j is now 3 and that 1. So we have this value 0 0 already, we have this. Okay, so this is this one, so 0, this 0 plus c1j 1 3, so 1 and 3, this we have already calculated, so 1 3 2 0, plus now this dimension 3 dimension we have, so 0 and 3 matrix actually we are taking, so this matrix and into that another matrix we have, that dimension 3 0 1 2 3, this one, 0, sorry, okay, j is now 3 and 1, yeah, this one. Okay, so this matrix and this we are getting. So okay, so what is the value of 0 0? This is 4. Okay, this 4. And what is the value of 0 1? That is 10. So that means 4 4 into 10 into, and what is the 3 1? Okay, so 3 1 is this 20. This is the value. Okay, so this value we are getting for k equal to 0. So what is the total value is this? So that is 1320 plus this is 4080. So this is approx 5003 or 5400, I think, something. So this one value we are getting. Same thing we will do for k equal to 1. Same for k equal to 2. Now just fill all this. Okay, so see that that is inductive structure.
Are we doing this week 12 or we are solving the problem today actually?
Yeah,
I
this is
just
the one
joined
query.
between.
Actually, this is one query. Just I am solving. Okay, from the week 9. After that, we will take week 12. Okay. So this is first is I. So this now I is will remain 0, and this k will value will be now 1. Okay. Now this time c k plus 1. So k plus 1 will become a 2, and j will remain 3. Plus now all these things we will do in the same way. So I, that I'm writing only the index. So d, that index is remain I equal to 0 and that 0. So 0 into d k. So k is now 1, index 1 into d j. So 3 and 1. Okay. So now what is the value of C01? So 01 value is 120. So 120 plus, and C23, 23 we have this 720. 720 plus and this multiplication. Okay, so 0 0 is now 4 into and 1 1. So 1 1 we have 3 into 3 1. So 3 1 we have this 20. Okay, so 120 plus 720 plus this 12 and 240. So you can see what we are getting now: 840 and 1080. You can see this
Okay.
value we are
Yeah,
getting.
got it.
Okay, and when you will calculate
Okay,
the
this is
for
what-
k equal to 2, then you will get some higher value for this.
Correct. Got it. Okay.
After that,
Thanks.
minimum
Yeah.
one.
Now I know. Yeah.
Okay. Okay, so now week 12. So basically, we have this string matching algorithm. So as per the name string matching, we are comparing some two strings. Okay, and one strings we generally called as a text, and another string we called as a pattern. So the text we have, we assume that we have the large text data, and in that data we are searching some small pattern. Okay, so that T and P, these the term we generally used in this string matching algorithm. So T means text and P means pattern. We are searching the pattern in the text. Okay, so how that searching happens efficiently? So the all these algorithms are related to that. Okay, so that searching in the document, in the text document, like, and this is very important algorithm. So how we can make these algorithm efficient, so our searching will become fast. So like you have daily that there are many applications which you use daily in the purpose. So like document searching, sometimes if you replace some word in the complete file, okay, use the control F, and you search the any particular string or some pattern. Sometimes you replace the pattern in all the place of your file. So in the document editor, like these all used actually these string matching algorithms, and that plagiarism algorithms, so that also use this string matching file similarity things. So we have already seen some algorithm in the week 9, that ED algorithm, edit distance, and that longest common subsequence, that are also used in the plagiarism checking. So these algorithms we will discuss in this week 12 content, uh, string matching algorithm. So we have some common name. The popular algorithms is Boyer-Murray algorithms, Raven-Karp algorithm, and that Knuth-Morris-Pratt algorithm. So KMP in we called as in the short. This is the three basic algorithms. Another, we have some another data structure is tries, that is also used for efficient searching and storing the data in some specific purpose. And regular expression is also used to search uh, the pattern in our text when we don't have the complete information for the searching. Some we have some idea like that starting character should be this, then how we can search the all word which satisfied that condition. So that is also one very useful uh, application in our database. Those who have completed the database course, I hope you know this like command, where we search the data which is starting from some key that character or ending some keyword like this. So that type of we use this regular expression. And this is actually very broad topic: finite automata, all these things, regular grammar. These are the very broad area to learn, but we professor have discussed in little bit about all these regular expression or finite automata in this to just give some idea. So now we will start from the basic naive approach for the string matching algorithm. So now first that you have understand that what is the main purpose of these algorithm. Okay, so we are searching some pattern in the text. So now brute force approach, you can see what how you can use the brute force approach. So suppose if you have character like this. So here this example is given like so this A, B, A, B, A, B, A. I have written some small part. Okay, so that we are searching. Suppose this is a text, and we are searching a pattern. So suppose we have pattern is AB, AB. Okay, so this we are searching that how many times our pattern is exist or it is exist or not, like this, and what place it is exist actually. So what is the naive approach said that we can start from the first index from the in the text, and we can start comparison like this. Okay, so A B A B. Okay, and we have just placed this pattern corresponding to the first index of the text. Okay, so this is the first index, or you can see start from the 0th index. Okay, so now we will start the comparison. Okay, so what we can do, we start the comparison character by character. So in this way, suppose the length of this is n and the length of this pattern is n. Okay, I'm just assuming this for the complexity. So A, we will match the character, first character. If first character is matched, then it is fine. We will move to the second character. If second character is also matched, we will move to the third character. Then if third character is matched, then we will move to the fourth character. If fourth is also matched, then we can say that yeah, our complete pattern is matched at this zero index. Okay, this index. After that, we will only shift one position, our pattern, to the next comparison, because our pattern can be matched to the next condition also, next index also. Suppose like this A B C like this, and our pattern is like this A. Okay, so this will be matched from the first index as well as it will also matched from the second index. Okay, so you can see it is also matched this part. This is matched this one. So because of that, we will shift our pattern one position to the right, and again we will start the same things. Okay, so now we have this A B A B. Okay, in this way we will match the character. If character is not matched, okay, so this first character is not matched, then what we will do, we will again shift our that pattern one position to the right. So in this way, this is the naive approach we can follow, and the same things we can do from the last position. Okay, so that not last position, we can start the comparison from the last character. Okay, so we will start the comparison from last character, and we can start the comparison like this, right to left. Okay, and at any time if our character is not matched, then we will shift one position to the right. If all characters are matched, then we will save the index where our pattern is matched. So this is the naive approach we can follow, but in the worst case situation, this will give the n into m time. Okay, what happens, suppose if our pattern is look like this, so our that the pattern text is look like this, a. I'm writing the complete. Okay. Hmm. And our pattern is look like this, so a b. Okay, so in this way what will happen, we will always start the comparison from first character, second character, third character, and fourth character. This will mismatch. Okay, so that means pattern is not matched. Now we will shift once again a b. Okay, so same things will happen again. So that means one this a will match, all three a will match, and next time this b will this not matched. So that means matching is failed. But what happened, we are doing the all m comparison every time. Okay, we are doing all m comparison of the pattern with the text m size. Okay, and then we are shifting one position to the right. So that means we are traversing all n minus m steps on this text, and every time we are performing our m comparison. So if you multiply this, you will get the m n. This is the worst case situation when we are getting this complexity for this naive approach. So this is the naive approach, and so this first in the
Sir,
notes.
one
Yes.
doubt there. This
Uh-huh.
the first given text and then pattern.
Hmm.
When we are comparing, we first four position it will take, right? First four position it will take and check whether AB is there in that given text. Am I right
Yes,
saying
yes,
so?
yes. So character by character we start the matching. Okay, so we will just place our m from the corresponding to the first index. Okay, so this 0 1 2 3. Okay, then we will start the comparison from character by character. So this a we will match with this a. If this is matched, then we will move to the next character. Then this is matched, then we will move to the next. Then this, if this is matched, then we will move to the next. If this is not matched, okay, so then that means our complete pattern is not matched. Then we will shift our pattern one position to the right. Okay, then we will start comparison corresponding to this one index. So that means a b like this. Okay, so then we will start comparison from this. This is not matched, again we will shift one position to the right. So in this way we are doing this. So this is one example,
Mm,
but this is the worst case situation. Second example is the worst case situation when every time we are performing m comparison, and at the last character we are found that our pattern is not matched. Then we shift one position to the right. Okay. So in this way, we will perform all these steps n minus 1 times. So that means m comparison n minus 1 times. Okay, so if you
Sir,
multiply this,
why it does not move? Let's say first iteration, it does not find the match. Okay, then it will try to go for the second loop. At that time, why it does not move the fifth? I mean the fifth position and then start comparison instead of starting from the second index.
no, but in this case, there is a chance you will not get the all matching actually. If you skipped all the things, maybe you will get a chance that the your pattern will be matched from the first index. There is a chance for that. You cannot skip completely like this.
No, after comparing the first set, when it is finding the match or not finding the match, either case, why the second loop it will start from the leaving the first
Okay,
character.
1 second. So I'm giving one example. So suppose you have this situation. So like A, B. Okay, and now you have the pattern, and again like you have this A. Okay, now you have the pattern like this A, this is the pattern. Okay, but here what happened, this is match, this is match, this is match, now this is not matched. But if you skip completely from the fifth characters, okay, then you will lose the pattern matched. If you can see your pattern is matched from this part. Okay, if you shift one position to the right, so that means A, B, now you can see pattern is matched completely.
Okay, got it.
Okay, so we cannot skip completely based on this part, these things. Okay, so in this way we have to shift only one position to the right, and we will compare this. Okay, so in this way we are getting this n into m time. This is the worst case situation. So how we can improve this? So the another next version professor have discussed is, if we, so in this situation what we are finding out that we are we are finding out the last character match. Okay, so we are starting from left to the right, and at the right last character is not matched. So what we can do, we can start from the right to left, but the same things will happen if all characters are matched from right to this position, and then last character is not. So this is just another version of naive approach. Okay, it improve little bit on the some case, but not this is the worst case situation. It also give the m into n complexity. Okay, so you can see only the implementation is little bit changed. So in this previous implementation, we are starting from the first index, so that j equal to 0, and then this is running now. This is the I loop, and this is for the pattern. Okay, so this j loop is for the pattern, and every time we are using this pj for the pattern, and this is in the text. Okay, so now j is starting from 0, so that means we are running from the left to right. But in the next implementation, you can see we are taking this j to the last index of the pattern. Okay, every time we are reducing this to the left side. So we are starting from the right position and to the left side. So only this is the change. Otherwise, we are doing the same things. But here also, so same situation may be occur. We we may match the difficult like this b. Sorry. Suppose our pattern for the same strings A, this one, and we have the pattern like B, A. Okay, so you will get the same situation. Okay, so this is matched now, this is matched, this is matched now, this is not matched. Now you will shift this to the right, and again this is matched, this is matched, this is matched, this is not matched. Okay, so in the same way you will get a m into n situation. So now this is the naive approach which we can think and we can follow for the string matching. This will give the correct output, but yeah, you will the complexity of this is n into m. So this is the only drawback. So how we can improve this? How we can speed up? So this text things. So the first algorithm is discussed is Boyer-Murray algorithms. Okay, so Boyer-Murray algorithms actually use this last indexing. Okay, so what is this last indexing? It's actually it is the pre-processing information for the pattern. Okay, and this this actually contain the information that like if you suppose if you have a pattern like A, B, C, D. Okay, suppose this is a pattern, and like suppose this is the A. Okay, this is the pattern. So this last, this is we generally follow as a dictionary or something we can use. So this last actually contain the information of each character in this. Okay, what character we are using in the pattern, and what is the last index in the pattern for that character. Okay, so now we have this A, last B, and last C, and last D. Okay, so we are using only 4 characters in this pattern. So okay, so this indexing is 0, 1, 2, 3, 4. So what is the last index of A in this pattern? So that actually this pre-processing things actually stored. So last index is now 4 for A. Okay, we have two. We have this at 2 place 0 and 4, but we will store the last index. Now, what is the last index for B? This is 1. What is the last index for C? This is 2. And what is the last index for D is 3. Okay, so I hope this is clear. So what is this last things, and how what information we are storing in this last dictionary. Okay, and for the pattern. So and these things we only perform in the pattern. Okay, so this is the pre-processing part of this Boyer-Murray algorithm, and then we use this pre-processing things, last information, to improve the time. Okay, so now you can see this is the algorithms Boyer-Murray, and we are maintaining this dictionary here. Okay, this dictionary, and this last dictionary is only storing the index. So this is only for the pattern. After that, we use this last information, and then we save some time. So how we save the time actually? So let's take the example for this. Okay, so this is not the good example. Let's take another one. Suppose we have the pattern like A, B, C, A, C, A, B, C. And now we have like this pattern A, C. Okay. Suppose this is a pattern. Okay, and this is the text. Now we will maintain a dictionary for that. We will maintain a dictionary for this pattern. So what will be the last information is A is now 0, 1, 2, 3. Okay, this is the indexing. So A will be 2 and C will be 3. Okay, so this is the last information. Last A index is 2 and last C index is 3 in our pattern. So now when we start the comparison, so A, C. Okay. So in this way, let me just check this. Starting from 0, that it is fine. Okay. 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 So now just go through this dry run. So now we will start the comparison from the first character. Now this is matched. Okay. This is matched. And now next character, this is not matched. Okay. If this character which is not matched with the corresponding character, okay, now we will check that what is the last index for this B character in the pattern, but it is not exist in our dictionary. So if it is not exist in the dictionary, that means we can completely skip our shifting till after this index. Okay, suppose what happens, suppose this is let me change little bit to understand better. Suppose this is also a. So the first character is meshed, second is meshed, third is not meshed. Now this B is not meshed with this. So in this case, what will happen? We will not shift one position to the right after this mismatching. Okay. What will actually we will check the last index for this B in our index, this dictionary. Okay. But B is not exist in this. That means what is the meaning of this? It is not exist in the pattern also. This B is not exist in the complete pattern. So there is a no meaning to shift only one position. We can completely shift after this B character this time. Okay, because B is not exist in the set of dictionary of these character of patterns. then we can completely shift our pattern after this character, because it will not match with any character because it is not exist. So here in the first step, when we found the mismatching, we can completely shift after this. So the next position of the matching will be from this position. Okay, so this like A, C. So here you can see how we are skipping our shifting. Okay, in this type of situation. Okay, now we found this is matched, this is matched, this is matched, this is matched. Okay, now this is the complete match. If we found the complete match, then we will perform only one shifting. Okay, so we will decide our shifting based on this last dictionary. Okay, if our pattern is matched, then we will perform only one shift to the right. So this is the main concept of this Boyer-Murray algorithms. And in the algorithms also, you can see we are doing the same things in this algorithm. I hope this is clear. How we are.
Sir, this
Yes.
index is dictionary is created for the pattern, not for the text.
Yeah, only pattern.
Okay.
Okay. Uh, and based on that, we decide the shifting. Actually, how much shifting we required. Okay. And you can see there are multiple situation comes like this. This is the when the all characters are matched, then how we will decide our shifting. At this step, this is the one situation when our character is not exist in the pattern, so that how we decide the shifting. If our character is existing, okay, then how we will decide the shifting. So all these three cases are there, and all these three cases are actually handled in this code. Okay, so I'll just go through the code little bit, and you will get the idea which of the part of the code is actually handling which type of situation. So here you can see this is the main basic code. Okay, when we are comparing the pattern or text character from left to right. Okay, so here okay, one second, please. No, we are not. Okay, we are just performing the shifting from right to left this way. Okay. So we can do in any way. Okay, but we will follow the same rule. So here we are using the right to left matching here. Okay, in the code implementation. So now you can see match equal to true, j equal to set to last that index of the pattern. And after that, while j is greater than equal to 0 or matched, this is condition is true. Okay, so we are initially set that our pattern is matched. At any point, if our pattern is the character is not matched, we set this to false. Okay, after that we check that another conditions. So here you can see we are matching our pattern character to text character. Okay, and this I is initialized with 0. So because 0 plus j, it will be set the that corresponding position. And we will set this I in the later based on this last dictionary or the other condition. So here you can see if character is not matched. Okay, so this condition is checked for not equal to. Then we will set our matched equal to false, and we will shift this j equal to j minus 1. This is the condition for the character matching, so that we are starting from the last character, and if our character is matched, still we will move to the left, and if our character is not matched, then still we will move to one time this j equal to j minus 1. After that, this loop will terminate. So this is the simple matching condition. After that, we are checking when the while loop is terminated. So either this while loop will terminate when our pattern will complete matched. Okay, otherwise it will be terminate in between when our character is not matched and this pattern is failed. Actually, pattern matching is failed with this pattern. Okay, at any point. So for after termination of this while loop, we are checking this first condition. If matched, so this matched equal to will remain true if our pattern is complete matched. Okay, if our pattern is complete matched, then it will remain true. In that case, we will storing our result in our list, then what index actually it is matched. Okay, so this post list actually contain the index when our pattern is complete match, starting index. We are storing this first, and then we are only increasing I equal to I plus 1. So that means we are increasing I, okay, to the one character to the right. So that means we are shifting our pattern only one position to the right. That, as I mentioned, that our condition when our pattern is matched, we will only shift one position to the right for the next matching. Okay, so this is the matched condition when our pattern is matched. Else, this part is actually when this match is not true and it is become false in between when our character is not matched at any point. In that case, because when our matched equal to false, when we make our matched equal to false, still we reduce this j equal to j minus 1 time. But that is actually not required for the false that when our matched is not happen. Because of that, we are again increasing this one to the position to the right. Okay, so that our character is not matched at this position, still we shifted one position to the right. Okay, but this is the fail condition. We need this information, this character information. So we will move back to the same index again. Okay, so we have increased this j equal to j plus 1, and after that these two conditions are required. One condition is if this text character which is actually not matched, okay, in the pattern is exist in the key or not. Okay, so this else part is basically for the when it is not exist. At that time we decide this I, and we are just adding this I equal to j plus 1. So this j is the that maximum length when our character is not matched. So we this suppose this is the position. Okay, at that time what is the value, what was the value of this j? So we will shift our pattern completely after this position. So because of that, we are adding this j value and then plus 1. Okay, so to the next position. So we are updating our I value to this new after this character. If our that character is not exist in our pattern. Okay, so this is the that type of condition when our text mismatched character is not exist in our pattern. So we are directly jumping after that. Otherwise, if it is exist, then we will look that last keys, what is the index of that last. Okay, so if suppose if our character is exist, then we will check what is the index of the last index of that character, and based on that we will shift our pattern like this. So I equal to I plus max of this j minus last of this mismatched character or 1. So sometimes what happen, you will get a negative, this j minus last this value, you will get a negative negative value. In that case, we have to shift only one position to the right. So we will pick the always we will pick the maximum among all the this j minus last and this one. Okay, so we will shift accordingly this I value. If our that j so that situation, let me just take that some example where this we will get the situation. Okay, so A, C, A, B, and then it's A, C. Okay, yeah. Suppose we are getting this situation like, okay, so now the indexing will remain same, A equal to 2 and C equal to 3. But what so in this case, because this algorithm is matching from the right to left, so we will start this matching from right to left. So suppose this A is not matched. Okay, this is A and C is not matched, but we will check what is the last index of this A. This is 2. So based on that, we will, because this is the last index of A, and based on that we will decide that what was the previous value of I was 0. For the first matching, I was 0, and then I plus, so I equal to I 0 plus and max. Okay, so max of j minus. So what is the corresponding j value at that time? So that 0, 1, 2, 3. So j value is now this 3. Okay, so 3 minus, and what is the last index of this? So what is the last value of this is 2. So 3 minus 2, you are getting 1. Okay, and we have the comma 1. This type of situation. So we are selecting the maximum among both value. So we are getting 1. So that means 0 plus 1. So I equal to 0 plus 1. And that means in this type of situation, we will only shift one position to the right. Okay, because we are getting the corresponding A only one position to the right. Okay, so that things we are getting from this formula. And based on that we will shift only one position to the right. Okay, so like A, C, like this type. Okay, and again we will start the comparison. So same things, you can see this is not matched. Okay, so same things, we will check the information and we will shift, decide our shift. Okay, so in this way we are deciding the shifting. And sometimes what happen, so like this negative situation things. 1 second. So A, sorry, B, B is not matched. Okay. Okay. So A, C, then A, C, then A, C. Okay. Suppose this is a text and this is the pattern A, C. Okay. So in this case, what will happen? So when we are getting this CC, it is matched. Then AA, it is matched. But this time it is failed. Okay. So now this 0, 1, 2, 3. This time when it is filled, J is now moving, pointing to this one index. Okay, and in this case we have the same information. Now A is exist at the 2 index last and C is 3. So now we will check this I equal to I. So I was 0 in the first comparison, so 0 plus max, and now J, so J is pointing to 1. Okay, so 1 minus. And what is the last value for this mismatch character C? This is actually 3. So 3, you can see you are getting this 3. Now comma 1. So here this time you are getting -2 and comma 1. So we cannot use this -2 for the movement. We can only use the positive thing. So if you are getting this type of situation, in that case we will only pick one position to the right. Okay, so this type of situation also we will only shift one position to the right. So then we will start checking again. So these are the 3 conditions we are maintaining in this, and in this way we can skip our shifting. We will not always shift one position to the right like the previous naive approach. In this way we can save some skip, and sometimes we can completely skip if our character is not exist in the pattern. We can directly come after that. Okay, so it will save some time, but also the worst case is still the same for this algorithm, but most of the time it will improve the complexity actually. So I hope this is clear, the basic idea of this algorithm, Boyer-Murray algorithm, how it is working, and the code part is also, I think it is clear. Otherwise you can just try to run this code and check.
So sorry. So what is happening is, if there is a not match case, that at what character this not match is happening, it will leave those many character, and then it will start again searching, right? And then
so
there
it
is
is
a
actually what it is doing when the character is not matched. It checks that what are the corresponding position in the pattern for this character which is not matched actually. So that it will decide the shifting based on that. Suppose this C is coming at this position here. Okay, then it will decide the shifting. So after the shifting, this C should become below this. Okay, if there suppose
basically,
yeah, like this. Okay,
with the pattern position, what is the index of the pattern character? Those many characters it will leave.
Yes, if this character is not exist completely, so you can directly skip after that, because it will not match with any character. If you are shifting one by one, definitely it is the wasting. Okay, so you can completely skip after that and you can start checking again. So in this way, this algorithm can save the shifting things and improve the time. But the same worst case situation is similar here. So that n into m time is still here for the worst case situation. So like you can see this condition is given. The text is t equal to same a like this, and you have the pattern like this b a. Okay, now this time a will get 0 1 2 3 3, and b is now that 0. But the same things, if you're matching here, then sorry, this one, then this is not matched. If this last character is not matched, then you can't do anything. So you have to shift one position to the right. Okay, so in this case you will always shift one position to the right, and this is the worst case situation, you will get the same complexity n into n as the previous we have discussed. Okay, so this is the first algorithm, Boyer-Murray algorithm. I hope this is clear. We can move to the next.
Yeah, yes, sir.
Okay. Okay, so next algorithm is Rabin-Karp algorithm, and this Rabin-Karp algorithm is actually use the that number matching things. Okay, so what this algorithm is does actually, it convert the string into the that numerical numbers. Okay, it's a numerical number, numerical digit, and after that we can match the digits. Okay, in the that constant time. So how it will work actually? So the professor have discussed this code, and this is actually given on the number itself only. Okay, so what happening? We have this. You can see this is the number, but it is actually a string. Okay,
So
but
is it converting the alphabets to the
yes,
ASCII
yes,
value or
yeah, that
index?
actually convert into the ASCII value. But here, this
Okay.
example which professor have discussed directly taking the digits inside the strings. Okay, to just explain the algorithm. But we have mentioned the other algorithm also, which actually convert the text into the number, then it will work actually. Okay, so you can see this algorithm also with this. So how it is working actually? So suppose we have this numerical digits inside the string. Okay, this is now text and this is the pattern. Okay, so what we will do, according to the algorithms, we take some prime number and we just check the reminder for the digit value. This is the actually concept of the Raven-Karp algorithm. You will not see this concept here in this algorithm. Okay, but so that means we are just getting the hashing value. We can say that. Okay, we will just get the reminder value. Suppose we are taking some reminder value for this. Okay, 23, and we are taking some prime equal to like 11. Okay, value we are, after that, for this we will just check the reminder value for this uh, pattern. Okay, so what is the reminder value we are getting for the pattern? So this is we are getting 1. Okay, and after getting this one, what we will do? So first thing, during the matching, okay, so what is the size of this pattern is 2 digit, then we will check this 2 digit here. Okay, and directly we will convert this into the digit integer number 23, and we will divide by the same the divisor value 11. Okay, so here, if our reminder is same, then there is a chance for the similarity. We cannot say that this is the exact match if our reminder is same. Okay, we cannot say that this is exact match, but there is a chance for the similarity. Okay, so here 23, we are getting the 23, and then we will divide by the 11 this 23 value, and then we will check the reminder. If reminder is same, then we will compare the text. Okay, we will compare the text one by one, character one by one. Okay, so this is the first thing. So there is a chance you will get the same reminder, but the number is not matched, because this is the division method we have already seen some place. I think in the hashing week 3. Okay, so this is the like collision type of things. So suppose we are getting the like this is 33, next value is the 33. Okay, so this 33. So 33, if we are dividing by 11, so we are getting 0 reminder. In this case, we can directly skip. If our reminder is not matched, then we can directly skip that part without checking each character of the string. Okay, but if reminder is matched, then we have to check character by character. So like next is 33 again. Now 32 is also a different reminder. Okay, so that can also be skipped. But suppose what happen if we have we have one 34. Suppose this place. Okay, so you can see this 34. Okay, now if you divide this 34 by 11, you will get a one reminder. But reminder is now same as the pattern, but still this is not matched. Okay, because of that, if we are getting the same reminder, we have to check all the character by character. If reminder is not same, we can completely skip. So this actually save the that suppose what is the size of pattern actually that we can completely skip. Suppose if size of pattern is 5 digit, so no need to match each digit character by character. If our reminder is not same, we can directly check this in the constant operation by getting the reminder comparison. Okay, so this is the concept of this Raven-Karp algorithm. So here this algorithm is given in the different way. So that pattern we are passing, that text we are passing here, but after that of the same size actually, what is the size of this pattern? We are getting this information uh, from this by the loop. Okay, so num both are actually getting the same size of the pattern. Okay, so 2 3 2 3, then after that we are matching this. If both value are matched, then we are storing the result. Okay, so this is the one fixed actually for the first comparison. After that we are just moving to the right, and then we are picking the next 2 digit by this code, and then we are directly comparison again. Okay, so num t equal to num p or not. So this is just a algorithm to give some idea. Otherwise, the main version of this algorithm you can see in the next implementation. So what we are doing, so you can see we have this text. Okay, this is now a characters. This is the pattern. Okay, and we are passing this text and pattern in our Raven-Karp algorithm. So how the Raven-Karp will work? So this is the list we are maintaining, and n and m. What is the length of text? What is the length of pattern? After that we are taking this some prime number. This is for the hashing purpose. Okay, this we will use for the hashing. And what we are doing, pattern hash. Okay, so this is the prime pattern hash. So we will get the pattern value. So how we are getting, we are calculating the sk value for each character. Okay, and we are adding all the sk value of the each character of the pattern. So what are the character A, D, A, B, C, D, B? For each character SKI value we are adding, and we are getting a pattern hash value for this. After that, finally we are just dividing by this prime number, that prime value 101, and we are getting some reminder value, and that we are storing in this value finally. Okay, so this is for pattern. Same things we will do for the text. Okay, now you can see text has, and for the same range, what is the length of pattern, this m we are running in the text, and we are just getting the all character sky value and adding these. After that we are calculating the same hash value by the same hash formula. Okay, this is the text hash. Now after getting this, we will that start the matching. Okay, so here you can see for I in range, this range, first we are checking this condition. So we have already calculated one time that text has equal to pattern has. If this is condition is true, okay, if the both reminder are same, then you can see we are also matching the pattern, that strings. Okay, so that means this text range part is actually matched by the pattern or not. So this is the direct string comparison. So here we are giving the same size string and we are performing the. So this will take the m steps actually. What are the steps of the pattern? Internally, it will take the same time. Okay, but this operation we are only doing when this first condition is true. You, if you know this pattern things, if you have two condition with the AND operation, if first condition is true, then second condition will be checked. Okay, if first condition is false, second condition will be skipped. Okay, it will not be checked, because according to the AND condition, both conditions should be true for the overall true. If first condition become false, no need to check the second condition because overall become false. So the compiler also perform like this way. So if first condition is false, this part will be not execute. Okay, this part will be not execute. Okay, first condition is true, then only part will be executed. So you can see we are matching the reminder part first, the hashing part. If it is matched, then we are performing the matching. Otherwise, we will skip. Then we will do the next iteration. And after matching, then we are just checking that if our I is less than n minus m, then we what we are doing in this, we are updating our text hash. Pattern hash will remain same, but text hash we will update. So how we are updating text in constant time here? So suppose in the text, okay, initially what what ASCII value we have calculated for this? A, B, C, D, B. Okay, 5 size. Okay, we have calculated the ASCII for this, and then we have compared. But now we need to shift one character more. So what we will do? We will include last character, this A. Okay. So to update our hash function, what we will do? We will reduce the hash ASCII value from this. Okay, and we will add the ASCII value for this. So from the total value, from the total hash that value, we will just remove the hash ASCII value of the first character, and we will add the ASCII value of the new character. Now we will check the same things again. Okay, so same things we are doing here. So text test minus what is the ASCII value of the first character, and then plus what we will add the ASCII value of the last character, and then we will again calculate the text hash by the that reminder formula. So in this way, we will move to the right, one position to the right, and we will perform the same again. So you can
Sir,
see, yes.
in this, so what we are doing is that pattern, we are converting that to ASCII value, and then that random prime number, that also getting converted to the ASCII value. Then we are doing a division and get the reminder. In this also we do that, right? That
Same things we are doing. So
yeah.
that means we are using this hashing function actually. This as
And
a hash function. It may be different. You can use another hash function. So what we are doing, we are just taking the simple hash function here to just understand. So we are getting some addition of each character ASCII value, and after that dividing by that prime number.
basically it will compare the hashing value after doing the same operation on the text also.
Yes.
If both matches, then yeah, otherwise it will move to the one character.
So if that hash value is matched, so this is a constant operation actually. We have that some integer value on the both side. So we are simply comparing that. If that reminder is same, then this part will be performed. If reminder is not same, then we will completely skip. We will not match that part. Okay. So in this case, in this case, we will skip this part for the many time when our character is that reminder is not same. Okay, so it will improve the complexity. Okay, so I hope this is clear. So what this Raven carp algorithm is doing? Yeah, so someone raised the hand, I think. Please ask. Nobody asked. Okay. Okay, so I am moving to the next. Okay, so I hope this is clear. So what the concept we are using in the Raven carp actually?
Sir, will this topics come for the entire exam, sir?
No, not come. Well, this is the additional extra content.
Okay. Sir, can you share the weightage for the interim exam, sir?
You complete syllabus week 1 to week 11 equal weightage.
Is there any important topics, sir?
So important topics you can see the PYQs, previous year questions. Topics I am saying that the weightage is equal, okay, for the each week. So that means you have already done that quiz 1, quiz 2. That means you have already learned the content. Now the just additional learning is week 9 and 11 only. So revise all the previous syllabus till week 8 and just learn this week 9 and 11.
Okay, sir.
Okay, and check some PYQs questions to get the idea of. So question will be similar to your quiz 1 and quiz 2 because that part is actually common. Okay, so revise that part also.
Okay, sir. Thank you, sir.
Okay, now this is the third algorithms, KMP algorithms.
In that Ravin Karp algorithm, what was the complexity?
Okay, so complexity is improved. So like this n plus m, you can see.
Okay.
Okay, so still it is worst case for general alphabets is nm, but it can be improved to this. That same things here also. The hashing function is important. You have to choose the hashing function if you can improve the hashing function properly, then that collision type of things uh, will help actually to save the time. Okay. Okay. So you can see also if we can choose Q value carefully to ensure constant surface match. Okay. So that means if we are getting a unique reminder, so that reminder should not be matched with the another value actually. If you can just select any good hashing function, then you can improve the time definitely. Okay, so one main actually key word is actually used as here, so that is match that that reminder can be matched for with a different value. So that is actually called here as a false matching. Okay, false positive. So that false positive is actually there are many questions you can see in the PYQ. So where the false positive is asked. So how many false positive are there? So false positive means when your reminder is matched, but the correct that pattern is not matched. So that is actually a false positive. Okay. Now move to the KMP algorithm. So KMP algorithm basically choose the different idea of the save the time actually, and that let me discuss. Yeah, so there are two same things. Pre-processor things is also there in the KMP algorithm. So that is called as a fail function, and this is the code for the fail function. And after that, we use the information of this fail function in our that final algorithms. Okay, so you can see this is the algorithms complete. The KMP fail provides some information, and then we use in the main algorithms. So what is this KMP fail information is actually? So here prefix and suffix, that type of information is actually provided by this fail function. And what is this actually? I'll take the example here. So suppose this is a pattern. Okay, this is the pattern, and like A B C A B C A. Okay, and what is the prefix and what is the suffix? So suppose we have the one example like A B. So what is the meaning of prefix? So prefix we can say that which string from the that suppose this is the pattern, strings substrings from the pattern which start from the first index, first character. Okay, that is called as a prefix. And suffix, that suffix is a substring, continuous string. Okay, so we are not talking about the subsequence here. Substrings we are talking. Subsequence, that is actually ends at the last character always. So that is called as a suffix. So what are the prefix possible for this strings? Okay, I'm talking for this strings. So that means A is the prefix. Okay, I'm writing P and suffix here. Okay, so A is the prefix which start with the first character. What are the other prefix possible is AA. Okay, that part. Okay, in general we not take the complete string as a prefix. Okay, so this is the only two prefix possible for this pattern AAB. What are the suffix possible for this is B. Okay, this one. And this is next is AB. This is the suffix. So I hope this is clear. Prefix and suffix. This is the main important part of this KMP.
Actually, I did not understand what is how to take prefix and suffix.
Okay, so according to the definition of prefix, prefix is a substrings of the given string which start from the first character.
Right.
Okay, suffix is a substring of the same given string which ends at the last character.
Okay.
Okay, now you can take any example like suppose A, B, C, D. This is the one strings you have. So what are the prefix possible for this is?
Okay, so you are saying the first place is the first character is the prefix, last character is the suffix.
Not only first character, the substring which start always from the first character. Substring means you can take part of the string that all characters should be come in the continuous. You cannot skip any character. Okay, but that string should be start always from the first character. So what are the
Okay,
substrings possible for this is A. Okay,
A possible, AB, ABC.
AB, yeah, AB, ABC, correct?
Hmm.
Always starting from the first character. AB. And what are the suffix? Which is always ends at the last character. Okay, so that means we will write, that means you can see we can take this, but we will write in the same order, left to right. Okay, so this D is possible, and if you take this, like CD is possible, and if you take this, BCD is possible. Okay, so each suffix is ending at the T, last character. Okay, clear?
Yeah, yeah.
Prefix and suffix. Yeah. So this is the first thing is need to know prefix and suffix or for any string. Now this fail function is actually check this information. So what is the prefix which is also a suffix of the string? What is the length of that? Okay, so what is the meaning of this? Suppose here you can take this example like A B C A B C A. Okay, now if we write the prefix so you can see here, if I consider this as a prefix, correct? This is a prefix, ABCA.
Yes, yes, yes.
And this is a suffix.
Suffix.
You can see both are match.
Correct.
Okay, and what is the length of this is 4. Which substring prefix and suffix is matched actually. The length of this is 4. Correct? So this information we calculate for the each part of the that string. So that means we have this A B C A B C A. Okay. Now this is the indexing we are maintaining here. So list in the list. So G corresponding 0, 1, 2, 3, 4, 5, 6, 7. Okay. So this is the index. And this information what we are getting, how we are getting this? Actually, suppose if we are only considering this strings, suppose we have this only A. So is there any prefix which is also a suffix in this? This is a single character. There is no prefix suffix possible. Okay. So because of that, length of the matched actually is 0. Because no prefix and suffix possible for that, 0. Okay.
So the whole pattern will not be taken as a prefix or suffix, right?
No.
At least
We are just at this index. We are only considering this string only. Okay. Where we will calculate the next here, so that we will consider this in string. So AB. This is the string. Find out the length of the prefix which is also a suffix in this AB.
Get it, but at any time the whole pattern will not be considered as a prefix or suffix.
No, yes, that whole will be not considered as a prefix and suffix. Yeah, correct. Okay, so here AB. Now AB, you can see A is the prefix and B is the suffix. Correct?
Right.
And both are not matched. That means 0 till this. Now move, increase one more length. So A, B, C. Okay. So now prefix is A and AB. Correct? And suffix is C and BC. Is there any matched in the prefix and suffix? Any matched? No.
No.
Okay. Nothing is matched actually. Okay. 0. Now if we add this one more. Okay. So A, B, C, A. Now prefix is I'm writing like this. So A, B, C. Correct. And suffix is A, C, B, C. Correct. Can you see the matching?
Yes.
Okay. So this is the matched. Okay. And we pick the maximum matching, maximum length. So this is the only matched actually. And what is the length of this? 1. That we will put here. Now increase the one more. So A, B, C, A. This. Okay. Now what is the prefix for this is A, B, C, B, C, A. Suffix is A, C, A, B, C, A. What are the matching? Again, only one. Correct? This is.
Yes.
And now increase one more. So like A, B, C, A, B. So this time you can see same way we can check, but this time you can see we will match this AB and this is AB. Here, this is the maximum matched. And what is the length of this is 2. If we
2, right?
increase,
This.
uh, and if we increase one more, so A, B, C, A, B, C. Now this time we have this match. Okay, length is 3. And if we increase the complete one, so that means length is 4. We have already seen. Okay, A, B, C, A, B, C, A, both. So in this way, for till each index, we are getting this information. So what is the maximum length of the prefix, which is also a suffix in that part. So this is the fail function information, which actually this function is actually calculate this function. Okay, and this return a this list, which we have just now calculated. Okay, this one. Okay, and after that, how we use this information in our KMP algorithm. So you can see this is the algorithms we have, and this is the same function we have seen, and this is returning a same list. Okay, which we have seen, and inside the function, the main algorithms, we are calling this function KMP fail, and it is returning this fail information. Okay, so till now this is the pre-processing part, and after that we start the comparison, character comparison. And here how we improve, how we skip the comparison, so that we use this prefix and suffix similarity information to save the time of comparison. So we can take some example like this. So suppose here the sample is given, so A, B, A, B, A, A, B, B, A, B, A. This is text and this is pattern A, B, A. This is a small example. Okay, so let me take some big pattern. A, B, A. Or just okay, so suppose this is the text, this is pattern. Okay, and we have this pattern, and then we will calculate the fail function for this. So that A, B, A, B, A. Okay, now this is a 0, and this is B, A, B still 0, A, B, A now 1. So A is A matched, and if we take one more A, so still it will remain 1, then it's still 2, and then 3. Okay, so this is the fail function information for this. Now how we save the time actually, so you can see we will start the comparison from the first character itself. So this is matched, this is matched, this is matched. Okay, now if this part is actually matched, now from here you can see we have the repetition of the prefix. Okay, so suppose this is matched, this is matched till this. Okay, and now this is actually failed, this is failed with this. So you can see we have repeated some matching actually in the pattern and text. We have matched this AB with this part. Okay, this one. And this AB is actually repeated here again. So this AB is again repeated because till this part we have this information like 2 matching. Okay, so this part we have the matching till 2 characters. That means this is the prefix which is also a suffix on this part in our pattern. So if this first is already we have compared with this first part, and during the matching we have also performed this AB with this part. Okay, so what we can do when our actually matching is failed, so we just check this information, what are the previous matched, okay, before this mismatching, in the previous match, what are the part actually which is also a prefix and also a suffix. So what we will do, we will shift our pattern corresponding to this position. So like this AB will be come below this, okay, will come below this, and we will continue start matching from this character. We are not changing the position of the I. Suppose if we are taking I and this is the now J for the pattern, when we are matching the character by character, and at any point if we are failing this, we are getting mismatching, so before that, in the part which we have already matched, we will check what is the part which is which is a prefix, which is also a suffix. So that means we can use this information and we can shift our pattern in this way, so that the text side, okay, so what are the suffix part actually will come corresponding to the prefix part of the pattern after shifting. Okay, because if this AB is already matched with this AB in the pattern, and that is also a prefix, so that means that is also matched with the prefix. So what we will do, we will shift our pattern in this way, so the prefixes will actually come below this AB, and we will not match again these characters. We will start comparison from the next character. So that means after shifting, our pattern will be moved like this. So ABA and ABA. Okay, so that part will now coming below of this. Okay, now this is already matched, and this information we are getting from the fail function. So this information we are getting from the fail function. How much shifting is required, and which part of the pattern should come below of the text part. And we will start comparison from the next character where we actually find out the mismatch. So this we will compare the B with corresponding to this A. This one. Okay, we will not match this further. So in this way, we can skip the this prefix and suffix information, and we can skip some our that shifting, and we can also skip the matching again if we have already matched any suffix part, okay, and which is also a prefix. So that means that part is also matched with the prefix. So that means we can shift our pattern corresponding to the suffix part, okay, and then we will start comparison from the same position again. So that is the chance where we can get the similarity again. Okay, so for more clarity, suppose if our pattern is look like this, so A B A A B B, and suppose our this is now text, and our pattern is look like this: A B. Okay, so this is not another things. Now we can take the word A B B. A B B and A B C. And this ABB, now this become ABC. Okay, so like you can see, suppose we have this type of information. Okay, so this is text, this is pattern. Okay, so in this way, what will happen? This is man, this is man, this is matched. Okay, so oh, this is not matched actually. ABC, ABC. Okay, keep the laser. So this is B suppose. So in this way, what we will get, so this ABC and this AB. So for this, suppose this is the pattern. So for this pattern, we will get this information 0, 0, then 0, and then 1, and then 2, and then 0. Okay. So this is the fill function for this. And after this, you can see till this point we are getting this two comparison. So that means this part and this part is matched. So when we are just comparing, so that means this is matched, this is matched, and this is mismatched. Okay, at this place. Now what will happen? So we will check before the mismatching what is the part which is actually mismatched. So you can see this AB is actually till this point. Till this point, we have this two information. So that means the in this strings we have the length of two prefix which is also a suffix. Based on that we will decide. So that means this part we will shift in this way. So this part will come below this after shifting. Okay, now our pattern will shift like this. So A, B, B, A, B, C. Okay, at this position. So you can see now this part we have already meshed with this part, and that means this is also meshed with this, because this is the we have the this information prefix suffix. So that means there's no need to mesh this part again. We will start comparison from the same character where we found the mismatch. Okay, so this way. So we will check with this only BB. Now this A, this is A, and this. Now this pattern is matched. Okay, so in this way we are skipping our that shifting, and we are also not matching the characters again. If any character is repeating as a prefix and suffix both are common, so we are not matching again, and we will start comparison from the next character. So that things is actually maintained by this function. So after getting this fail information, you can see we are just running a while loop, and we are matching the characters. So TJ and PK pattern. This K is using for the pattern, and this is for the text. And this condition. So what this condition is? If our K is reached at the m-1, so that means last index. We have start comparison. So K is pointing to the pattern character. So that 0, 1, 2, 3, 4, 5. In this way, if our K value reached at this last index, so that means after this character match, and our K is already reached at the last index, that means our complete pattern is matched. So at that time, we will store our result. Okay, and we will reset our K to 0, and we will shift our J to one position to the right actually. Okay, so in this way we are just using this J minus M plus 2. So if you use this formula, you will get only one position to the right actually. Okay, that pattern will be shifting only one position to the right. So here we are not doing anything if our pattern is matched completely, and then we will shift only one character to the right. Else, otherwise, if our pattern is not matched, then what we are doing? We are just increasing our J and K to the one position to the right, both. Okay. Okay, this is corresponding to this if condition. Okay, if K is not okay, yeah. So this is just a iteration of the while loop. If our character is matched, but we have not reached at the last index, that means some characters are more remaining for the matching. So in that case, we'll simply shifting our J and K both to the one position to the right for the next character matching. So this is the part for the matching. Okay, if we have complete matched, then we are storing the result, or we are resetting our J value to the K value to the 0, and J value we are moving to the one position to the right, and otherwise we are moving to the next character in the both pattern and text. And this is the first condition. This is the second condition we have. If that this means if this condition is not matched, if our character is not matched any position, in that case we will check if our K value is greater than 0. That means if our K is not matched, that K index, and it is greater than 0, so that means if our pattern is mismatched at the in between, not at the first character. Okay, so it is greater than 0. So in that case, we will just reset our K to the fail function of this value. You can see we are reading the fail function value for K minus 1, because our K is not matched. Okay, so we will check the previous character fail function value, and we will reset our fail function to this value fail function. So this is the same things you can see. So what is the meaning of this? This is the meaning that our I is still, sorry, J we are using. So J is still set to this mismatch character only we are resetting our k index. So we will shift our k index to this one value. Okay, 2. So you can see this is the 2 value. So that means 0, 1, 2. This a. So next time our matching will start from the same j position to the new reset k position. So that is just the next character of the prefix part. So that means all shifting is happen in the same way. Otherwise, if our k is reached at the 0, so that in that case, so that means nothing is remaining in the text pattern. The last character is actually mismatch. So in that way, we will only shift one position to the right. Okay, so this is the like a similar condition of the previous one. So this is the main part where we are skipping the pattern based on the prefix and suffix information. This elif condition. Okay, and we will save the comparison. So this is the KMP algorithm actually.
Mhm. Any better? This gives better
Yes, so
complexity.
this is also give the complexity. So here you can see, if you see this code is running for the pattern this j is less than m. Okay, so complexity of this is also only big O of m, and the find function you can see we are running only for this j equal to n, this n loop, because we are not resetting our j sorry j value at any point, okay, to the previous position. J is continuously moving, and we are only resetting our k position, pattern position, okay, to the previous location. So that means this is single a big of n time iteration with the help of this. So in this way you have this only big O m plus big O n. So if you add both, so you are getting this big O m plus n complexity for this. So this is much better of the big O of m n. This one. This is the multiplication. This is the addition. Okay. Now professor have discussed this prefix and suffix part with the help of finite automata. So if this part is clear, what we are talking about, this prefix and suffix things, so I think you don't need to go in that topic, that finite automata, because that finite automata, this is completely a new course actually, and you will just become confused. So if you just understand all this prefix and suffix things, so professor have just explained all this prefix and suffix, that part using the finite automata, so you can skip that, okay, for this algorithm, because professor have discussed this prefix and suffix first with the finite automata, and after that professor have discussed this KMP algorithm. So I have explained this prefix and suffix with the example. If this is clear, you can skip that part. Otherwise you will maybe confused, because you, if you don't know the finite automata, all these things, basic things, then you will not get that part. Okay, but this is the main actually algorithms which actually professor wanted to discuss. Before that, professor just used that finite automata concept to explain this prefix suffix part. Okay, so this is the third algorithm we have for the string matching. So this is the main three algorithms we have, string matching algorithm. Another next topic is try. So try data, this is a data structure, special kind of data structure. So this is just use the tree type of structure, uh, and this is used for the information retrieval. So there is one common example, like if you have this type of information like dictionary. If you see the dictionary where the lots of words are there, okay, so and in the dictionary, and many of the words actually use the same prefix type of things. Okay, so here you can see beer and bell. Be is the common. Okay, here if you see this, in all these five words, b is actually common. Okay, so like in the dictionary, many of the word you will find out that the some part of the word actually is common for the many words. So how we can store this type of information in a good structure, so we can retrieve quickly and we can store also in the quickly. So we generally use this try data structure for this, and we create a node for the each character, but we use the node as a common character. Suppose you can see here, so this is the root node for this trie structure. If we want to store this bear word in this, okay, so what we will do, we will read the character b. First we will check if b is already exist or not exist, then we will create a node. Then e, then we will check in the child of this b, e is exist or not. Okay, so e is not exist, then we will create the e. If then a, then we will check the a as a child of e. Okay, then if it is not exist, then we will create this. And then r, same things. Okay, and this is the some identification we will give as a, this is a last character, so we can add some special character like dollar, all these things. So like this, that will just a identification of the, this is the termination word, the terminate point. So in this way you can see we are getting this word by root to leaf node. Okay, so bear. And if we want to store another word like bell, which contain the common prefix, okay, so we will not store the again that character information in the memory. We will use that common information from the previous. So like b, you can see b is already there. Okay, now we will check the, we will move to this b. Then e is again already there. Okay, we will use this e. Then l is not there, then we will add new. And then again l, so l is the child, l is not exist as a child of l, then we will create again. So in this way you can see we are just adding two new node in this, and we are getting this same bid. So b we have already there, I is not there, we have added this, and then d. So in this way we are creating this structure. Now you can see what is the depth of this, what is the maximum depth of this. This is the maximum length of any word. Okay, in the all word, what is the maximum length of this word? Stop. So this is the maximum length, this is going. Okay, so in all the words you can store, that means if you want to store any new word and that word contain only 5 characters, so you need only 5 steps to store that. Okay, so here you can see bull. So how many steps are required to store this new word bull? So you need to only move only till 4 depth. Okay, so you just check this b is exist or not. If exist, then move to that node. U is not exist, just create a new node. L, then L. Okay, so that means what is the length of that word? That is the steps required to store that word into your data structure.
So but here no logic is applied. Just random, like whatever comes first that goes, and then whatever next character
Yeah.
it will go down.
But we are using this common prefix information. Okay, so in many of the word we are using the common characters as a prefix, so that we are not creating again, we are using the same. So in this way we are that saving the space also, and we are also improving the storing time in our data structure. And later you can search any word in the same length of the word time maximum. Okay, so suppose if after creating this type of structure, suppose you have the dictionary where the million of the words are stored in this structure, and you can search simply, you can search any word in the same way. Suppose you, after storing this, you want to store this bull. So same things, you what you will do, you will check the b first, and then you will move to the b, and that u is exist as a child of this b or not, so that we can maintain using the dictionary. So we can check this information in the constant time. So u is now exist, yes, move to that. L, yeah, L is that, then L, the L is that. After that we will check this is there any terminate symbol is connected before the after this. So that will be the identification that this is the complete word we have already in the dictionary. Okay, that this is exist. So same length is the required to just check that word is exist or not. What is the length of the word? So this is the time required to store and the search as well. So this concept we are using here. Now you can see this is the implementation of this trie, and we are using the dictionary. Okay, we are using the dictionary. That means this is the root. We are giving these names, and this is a key actually for the dictionary. This is the key, uh, and then this is the value, and the value is also a again a new dictionary. So that means corresponding to key, we have the inside the value we have another dictionary. So like B, okay, and inside for the value of B we have another dictionary. Okay, EI like this. Okay, so in this way we are using the nested dictionary type of structure. So why we are using dictionary? Because in dictionary we can check any key in the constant time. Okay, we can search any key in the constant time. Because of that we are using all the dictionary, nested dictionary. So inside the value again we are creating a dictionary. So in this way this is now become a nested dictionary type of structure, and the logical structure will represent like this in the tree form, and then we can store and search any data in the length of the word time. So here you can see that we have created this try class. After that this is the add function. Okay, when we are adding this, so we are just adding this terminate symbol sum, so this will become just like a identification of the word end. Okay, and after that we are just using the we are running a loop in the dictionary, and we are moving to child like this, key to value, then value to next value in this way, and we are reaching at the last position where if our key character is not exist in the key, then we are creating, you can see we are creating a new dictionary. This is again a dictionary with the key C. In this way we are continuously moving to the end point, and you can see already we have added a new character as a terminate point. So this is for the addition time, and you can see this loop is running only for the what is the length of the strings which we are adding. So this is the complexity for this same query. That means searching is also going in the same way, running in the loop, and if we are reaching at the if at any point if character is not, that C character is not exist in the key, then we can directly return false. That means that character, that word is not exist. Otherwise we will make that as a we will move to the child, and at last if we have reached at the doll that special symbol and symbol, then we will return as the answer true. If we not found this, then return as false. So you can see this we are implementing using the dictionary, this try data structure. So this is one application, you can save lots of time to store the data and search the data of this type when the data contains the that common prefix things. This is try data structure, and there are some other application. This have actually suffix try. We can find out the all prefix suffix information if we have this type of data structure.
So
So
what is the complexity of this? Is it any better, or it
yeah, this
is
the complexity is depends on the word length. What word we are storing? Suppose this we are storing TAR. What is the length of
okay?
it?
Okay, got it. So it will be more. The height will be more actually.
So that means we need to traverse only 3 depth in this case. If this is 4, then we need to traverse only 4 depth. So 4 steps are required. Complexities depends on the word length.
But it saves a lot of space in the way
Yes.
it stores
Yeah.
for comparing.
Yes. It is actually saving the space also. It is also taking less time for searching and as well as the storing. So this is actually very useful that data structure when we want to store the data which have the many things actually common information. So like the dictionary is the best example to explain this. Okay, after that, if we can also use this suffix and prefix information in this data structure. So what are the suffix? So same things we use the. These are some example other purpose of this try data structure you can just explore. So same data structure we are using. Okay. So that's the other is like that regular expression. That is also a very big topic actually. If let me open the slides. That
So this week 12 is not added in the GitHub. That index page was shared earlier, right? It's not there
no, it
anymore.
is there.
No, it's not there as a.
It is as a big 10.
So it's there as a week 10.
I'm just exploring with the that. side is yeah, this one. No? Week 9 is there, then week 10 is actually mentioned here. That same thing you can see. Same page I'm using. Okay. So regular expression, this part is actually some required more knowledge. Let me just quickly discuss with the help of slides. Yeah. If you have already used the, if you have already done the DBMS course, I hope you know this things. So what is this?
Like operator.
Yeah, like operator. Suppose uh, if you want to search a data, that is actually where the name start with this like A. Okay. So suppose if you have some database and you want to search the pattern, and here pattern is not given as the complete pattern. You have some information like the pattern is starting with A, and after that you don't know. So that means all the name which actually start with this A, okay, that will return as a answer. So here we are not searching the complete pattern. We are giving some information. That means this part should be matched. After that, the another part may be anything. And we can give another way also. So like we can give like this. This is that pattern should be start with A. The middle part may be anything, and the last character should be D, like this. Okay. So all the name, if you are searching with the name database, so that means the all names which are starting from A and ending with the D, and in between any strings may be happen. Okay, so all will be written as the things. Okay, so this type of matching actually called as a regular with the help of regular expression. So this is also a pattern matchings in the text, but here this we are not using the fixed pattern. Okay, so that means that so far we have done the fixed pattern here, but here we are looking in the different way. So that you can see unsure of the spelling. Search every that you are not sure of the spelling for the searching content. So what you can do, you can just give the starting part of the name, and then you can figure out that what are the matching actually corresponding to this. So there are multiple way. If you just see the regular expression, that means this finite alphabets. So there are other information is also required. This is just an idea, and we use some specific terminology for this. So this union subtraction like this. Let me give some another example where it is. Yeah, so you can see this type of character. The to match the start of the strings, right? That this things. Okay, so the string should be start with this P. So all will be matched. We are using this operator. Okay. So this is just an explanation. Otherwise, in the in any application, you can maybe used in the different symbols. So like you have used in the DBMS. So this the match the start of the strings, right? Is P. The match start of the string, right? Okay, the start of the string, same things is there. Okay, so this representation may be different like this, and there are multiple used like this. Hmm. So you can see BA and A. So that means the string should be start with BA, end with NA. This is the end point. So any strings you can see it is matched like this. So there are multiple way to just this regular expression. So regular expression is used to searching the pattern like this. So the professor have discussed some idea, not explain any algorithm specific for this. So this concept is actually used for the matching where our pattern is not fixed. You have some information and you want to get the matching corresponding to this. Okay. So for this, you I think not required too much corresponding to this course. You can explore if required. So this is the string matching algorithm which we have discussed just now. That is the main actually. Okay. This is the additional things. Okay, I hope this matching algorithm are clear.
Yeah, got some idea. I think we can explore
Uh-huh.
further.
Okay. So later, maybe after completing of this course, just explore this. Okay, so that will be helpful at some point later.
Actually, these are pretty useful. I mean,
Yes.
it is very widely used.
Hmm.
And
Yeah, because of that, I'm saying after completion of this course, still just explore the content of this. Okay, so because maybe sometime at in the future you will get useful to this information required.
yeah, sure,
Okay.
sir. This one. When the result will come for the OPP? Any idea? Though I have
Uh,
not done really well in. Uh,
okay. Actually, there's one more shift is pending on the 25. Okay. So this time we have three slots for the OPP, PDSA OPP. Two have already done on the 18th. One slot is still remaining on the 25. After that, all the result will be compiled.
Actually, for the DBMS, like they gave REOPP like some technical problem something. The PDSA there was only one slot, and this I
Like,
mean just hmm?
so we haven't received any complaint actually
No,
because all things went well.
I get that, but my one request, like in the future also, like if it is taken to OPP, like there is a better possibility that the students are scoring good actually, because
Best of two.
yeah, best of two. What happens is on that day, like it's I mean, I should not say like that, but sometime on luck also, like what I have practiced. And but though I understand that that should not be the intention, that luck based, but
Mhm.
If operationally feasible, best of two is always better.
This is the main actually problem actually because here we are not using any passing criteria. Because of that, professor suggests only one OPP exam and with only 20% weightage, but without any passing criteria.
look,
So this
what
is the
happens is
additional things to just test your that problem solving skills and the coding skills, but not because DSA concept is should be know as the concept level actually, not much on the coding level actually. Okay, most of the time in the additional and the offline colleges also you will see that this DSA course is not teach as the coding level, only just they teach as the
yeah,
concept level.
I understand, because see,
Huh.
if we know this algorithm, at least after going through, we at least know that KMP algorithm is better for the pattern matching. Just saying, or let's say this try algorithm.